Okay, function notation. This is a concept that sometimes is kind of rushed through in algebra, but it's so important that I wanted to spend a fair amount of time on it today. And it's going to be very important for EOC. EOC is going to take us to deeper levels of understanding, or it's going to test deeper levels of understanding. So hopefully by the end of the day, I can help you understand when and why we use function notation. Our objective is I will learn what function notation means and how to use it. Well, what is it? Well, in a nutshell, it's another way to identify a graph or a function. It's another name. Functions can be written in two formats, and you've already written this down in your notes. We've been looking at the y format, or the y equals format, where y equals some work done to x, like 3x plus 5, or y equals something like 2x squared plus 1, or y equals something like x divided by 3. Another way to write those same functions is to replace that y with f of x, g of x, h of x, cat of x, tuba of x, you know my cat and tuba. It's just another name. So if we replaced y with f of x in the first equation, it would be f of x equals 3x plus 1. I'm going to replace this y with g of x, and everything else is the same. And then this y with h of x, everything else is the same. It's just another name. We're just replacing y with some other name. Now, why in the world would we want to do that? It's already confusing enough with y, right?
Yes.
Okay. Well, there's two reasons that we want to do this. And the first one is that we give different functions different names that are more meaningful. And I'll show you that by an example in a few minutes. And the second reason is you can use this type of notation to tell what number you're plugging in for x. Okay? So what we would do is we would replace like this h of x. If I were going to evaluate this for x equals 2, I would put a 2 here. And then a 2 there. And it would tell you what I'm plugging in for x. Okay, the best way to learn this is just to work an example. So if you'll flip over or just turn to the next page or right across the way.
Page 18?
Yes, page 18 for y'all. I'm going to actually write these examples. Let's say we have an f of x equation that says f of x equals 3x plus 5. Fairly harmless. I want to evaluate that equation for a couple of different x's. I'm just going to draw this. There's nothing magic about this little chart. It just gives me somewhere to write. I'm going to look at it for f of minus 2 and f of 1. Now, all that means is that when I run into an x in the equation, I'm going to put in these numbers. So, f of negative 2 in this equation would look like this. F of negative 2 equals 3 times negative 2 plus 5. Now, from our order of operations exercise yesterday, what's this going to be? F of negative 2 is going to be 3 times the negative 2. Negative 6 plus 1. So f of negative 2 is?
7.
Oh, sorry, that's
negative
5. I'm so sorry. That's supposed to be a 5. Negative 1. Okay? So what we would say is, when we answer this question, the f of negative 2 in this function is 1. Negative 1. All right, let's do the same thing for f of 1. I'm just plugging in 1 into that same equation. So this is my right. F of 1 is 3 times 1 plus 5. F of 1 is 3 plus 5. So when x is 1, f is. So what does that mean? Right? Let's look at it. Let's look closer. What is our domain in this situation? Okay, first of all, what is domain?
Range is the X. Not the range, the opposite of the range. X.
It's your x's. Okay, what were my x's in this
F2.
situation?
-2.
-2. And what else?
-1 is your
That's
Y.
positive 1. Okay, look at that. You could pull out your domain. All right, let's think a minute. What is your, if this is the domain, what is your range?
3x and 5, or 3 and 5.
No.
F and
Okay,
F.
what is range?
The y.
The y's. What is our y's in this case?
F and x.
F of x.
F of
So
F
what
X.
was our f of -2?
-1.
So our range, our output, when our input was -2, our output was 1. Okay? So 1 and 8. These are your inputs.
-1 and 8.
Now, there's another piece of information that you can dig out of this. And that is, how would you write a ordered pair using function notation? Okay, first of all, how do you write an ordered pair? Generally,
X and y.
x and y, right? X and y. That's an ordered pair, where x is your what? Inputs.
Input.
Y is your,
Output.
okay, x is your domain, y is your,
Range.
okay. How are you going to do an ordered pair in function notation? And I'm going to say f of x format. What's it going to look like? Is the x going to change? It's going to still be an x, right? What is the y now?
The number.
What is y up here?
I don't know. Nothing.
Oh, the answer.
F.
F of x. Okay.
That's X.
Okay. So if I'm just replacing y with f of x up here, if I'm going to do an ordered pair, I'm just doing the same thing. It's x and f of x. F of x is the function of x. It's what happens when you put x in. It's the output of x. It's the range. I know, it's words. We've got to learn our words.
Do we have a worksheet?
In just a minute. Okay. Now, all of that is fine and dandy. How are you going to see something like this on a test? This is what you want to pay attention to right here. Example. This is test example. And guess who makes out the test?
Yeah.
And so I would pay attention to this.
Do we have a test where we give it to you?
Oh, sure.
For real?
Can we?
A math test?
Yes. I can make you fail.
No, not my subject.
I think I can make
I'm sorry. F of x is 2x plus 2. That's the function. Now here's the, then it's giving you this information. The domain of the function is then you're given this notation. Okay? Now here's the question. Find the range and two ordered pairs from this function. Thursday.
Oh.
How would you approach this problem? Okay, what's your domain? But what is domain? Input, which is the x's. Okay, so here we go. I have f of x is 2x plus 2. Why don't I just plug in these numbers for x? Okay, so f of 2 is 2 times 2 plus 2, which is 4 plus 2, 6. Okay, f of 3 is 2 times 3 plus 2, which is 8. Okay, go ahead and write that down. Oh, I'm almost done. In my domain, and I'm looking for my range, so what is this that popped out over here? What are these numbers? Yeah. If these are my domains, what is this that's over here? The range. It's the output, right? So I'm answering the first part of the question. My range is 6 and 8. Imagine that. Okay. Now, I'm going to go ahead and write my domain right above it so I can see things a little clearly. All right. My domain are my which x or f of x's? X's. My ranges are my y's. Okay, so now I need 2 ordered pairs from this function. What are 2 ordered pairs? I need an x and a y for each one. 2 and a 6. Because when I put in 2, I get out a 6, right? And the other one is when I put in a 3, I get out an 8.